What's up? I'm Van, and I'm going to go through the Algebra 2 Regents from January 2025, and I'll leave a link to a copy of this test in the description below. Now let's get started. So first, we have the Part 1 24 multiple choice questions, and each question here is worth 2 credits. Question 1, the exact value of sine of 8 pi over 3 is... So for this one, we could just type right in the calculator, and just know if the calculator has been reset, the default is radian mode, and we have an angle on the inside in radians. So I'm just going to press sine of 8 pi over 3, and I'll press alpha y equals enter to pull up a blank fraction. And we have 8 pi over 3. So we just type this in like this. We press enter, and let me just fix that a bit. So I'm going to hit the right arrow to get out, close the parentheses, press enter, and this is the decimal value that I'm looking for. And I notice right away that the answer is positive, so I'm only going to look at choices 1 and 4. I know 1/2 is equal to 0.5, so it has to be choice 4. And let me just double check. We have square root of 3, and then we divide by 2. Okay, and we get the exact same decimal here. So choice 4 is our answer. Now, one extra thing I want to point out is if we do this without a calculator, it's a little bit more challenging, but it could still be done. So I look at the angle on the inside, and just know that whenever you're evaluating a trig function, you could always do plus or minus 360 degrees. But when you're in radians, you could say plus or minus 2 pi. So in this case here, I would want to go with the radian approach. And in this case, I'm going to subtract 2 pi because my goal is to make this angle some value between 0 and 2 pi. Okay, so I'm just thinking of the xy axis. And I know that on the xy axis, we have 0, then we have pi over 2, then we have pi radians, and then we have 3 pi over 2 radians, and then we have 2 pi radians if we go full circle. So 8 pi over 3 is more than 2 pi because 8 divided by 3 is greater than 2. So that's how I know I'm going to subtract 2 pi from the inside. And once again, this is if you want to do this without a calculator. So I have 8 pi over 3, and I subtract 2 pi on the inside, and it's going to be equivalent to what we started with here. So now I'm going to have sine of, and if I subtract these values here, I'll do 8 over 3 minus 2. I'm going to call 6 divided by 3, so we have common denominators, and that gives us 2 over 3. Okay, so we have sine of 2 pi over 3. But then the next thing to know, if you don't recognize this angle right away, is how to go from radians to degrees. So when you want to go from radians to degrees, you multiply by 180 degrees and then over pi. And the pi's cancel like this. And then if I simplify, I have 180 divided by 3 is 60, and 60 times 2 is 120. Okay, so I'm just thinking of a 120 degree angle, which is going to bring us over here. So we're going to be in quadrant 2, and the thing to know from here is ASTC, which stands for all students take crack. No, I'm just kidding. This stands for all sine, tangent, cosine. That when you have an angle that terminates in quadrant 2, the only function that's going to give you something positive is going to be sine and its reciprocal. Okay, so the fact that we're finding sine of 2 pi over 3 and we're in quadrant 2 here, so this is a quadrant 2 angle, tells us that our answer is going to be positive. But then the next thing to look for is the reference angle. So I have a 120 degree angle from standard position. The reference angle is the positive acute angle between the x-axis and the terminal side, which is 60 degrees here. So this tells us that if we want to find our answer, what we could do is we could just find sine of 60 degrees. Okay, so we're going to do over here, we're going to do sine of 60 degrees. So it's going to be plus sine of 60 degrees, and sine of 60 degrees is equal to square root 3 over 2. Okay, so this would be the no calculator approach. But look, for a question like this, just type the original expression in the calculator and then look for the matching decimal. Either way, we're getting choice 4. Question 2, a teacher randomly divides all of her students into 2 groups. She grades the homework for one group, but does not grade the homework for the other group. All homework is returned to the students. She then compares test scores for each of the groups to see if grading homework has an effect on the test scores. This method of data collection is best described as, and we have these options here. Well, the fact that we have one group that is being experimented on here. So notice in the question, if we reread it, that we have that she grades the homework for one group, but she does not grade the homework for the other group. Okay, so this is what we call a controlled experiment. The control group is the one that doesn't get the intervention, and the experimental group is the one that we're trying to see if there's an effect on. So the experimental group would be the one where the teacher is actually grading their homeworks. So that's how I know right away it's going to be choice 1. This is not an unbiased survey because, once again, the students aren't actually answering a survey here. The teacher is just trying to see if there's a difference in the test scores based on, some idea that she's implementing. The simulation, this is not going to be the answer choice here because it's not like she's running some event 100 times in a computer or something. So that's how I know it's not a simulation. And it's not an observational study because, once again, the teacher is influencing the environment. She is purposefully making two groups here, one where she's grading homework and one where she's not grading homework. So an observation would be she's sort of hands off in that process, but she's absolutely affecting the environment here. So that's how we know it's not 4. Definitely choice 1. Question 3, which expression is equivalent to, and we have this quadratic expression here. So for this one, the expression is not looking so nice. This part here, the x minus 2 squared and then plus 27x minus 2. This would be much nicer if this said x squared plus 27x minus 90. But I'm not going to just replace these with an x. I'm actually going to say u equals and then x minus 2. You don't have to do this by substitution, but I just find it's much easier for students to handle this when they do a substitution here. So if we plug this into the original expression, we're going to have u squared, and then we're going to have plus 27u, and then minus 90. Okay, so we're just replacing the x minus 2's with the letter u here. And now this will factor much easier. We're going to look for two numbers that have a sum of 27, and the two numbers also have to have a product of negative 90. So if you think about it, it's going to be positive 30 and negative 3. And we can see here 30 plus negative 3 is 27, and the product of 30 and negative 3 is negative 90. And now what we could do is we could just substitute back in. So this part here, u equals x minus 2, I'm going to replace the u terms here with x minus 2. So we're going to do that in the next line here. We're going to have x minus 2 and then plus 30. And then we're going to multiply that by x minus 2 and then minus 3 here. So once again, I'm just replacing the u term over here with x minus 2. And now all we have to do is just simplify. So this is going to work out to, we're going to have x and then minus 2 plus 30 is positive 28. And then we have x minus 2 minus 3 is minus 5. So now we scan the answer choices here, and this is going to match up with choice 2. Now remember, for the Regents, you do get 3 hours. So even though this might be time consuming, you can type in the original question here, and you could type in the answer choices and see which ones match. So we have x minus 2 squared, and then we have plus 27 parentheses x minus 2, and then we tack on the minus 90 at the end. And now I just keep typing in answer choices until I get to choice 2. So we have x plus 28 in the first parenthesis, and then in the next set of parentheses we have x minus 5. And I press graph, and notice that my graphs overlap. If I press second graph, my table is matching completely here, so 2 is definitely it. If I type in one of the wrong answers, so let's say I were to type in something like choice 1. So I have x plus 30, and then I have x minus 3 at the end, so x minus 3. The wrong answer, if we notice, is going to give us graphs that do not overlap. And if we look at the table here, the y values are different. So that's how I know 1 is not the answer, but once again, 2 is going to be our answer choice. Question 4, given the functions f of x and g of x, what are the solutions to f of x equals g of x? So for this question, one of my coworkers actually pointed out something really cool. The question is asking for what are the solutions to f of x equals g of x, which means that the answers have to be in the form of x equals. So right away, if we look, the only answer choice that has the answers in the form of x equals are over here at choice 2. So the other answer choices, the reason why they're no good is choice 1 has the answer in the form of x comma y. And then here we have the answers in the form of the y values. And then choice 4, once again, we have an x comma y. So logically speaking, 2 is the only possible answer choice. But if we wanted to find the answer choice ourselves, we could just type this right in the calculator. So I'm going to go over to the y equals, and we're going to have 2x and then plus 5 over 2. So I'm going to press 5 divided by 2. And then for y2, we're going to have 3 over x. And then I press graph. And notice that we have 2 points of intersection here. I press second trace 5 to look at the intersection points. So I go over to the intersection. I get nearby, and I press enter 3 times. And we have one at x equals negative 2, y equals negative 1.5. So there's the x equals negative 2 solution. And then second trace 5 will tell me the next one. I scroll nearby, and I'm just going to guess here that it's going to be x equals 0.75. We press enter 3 times, and there it is. There's the match. So we could use the calculator to trace here where the graphs intersect. Now, one last method would be to solve this by hand. So we could set 2x plus 5 over 2 equal to 3 over x. And then from here, I noticed that the least common denominator of all of these expressions is 2x. So I'm going to multiply everything by 2x, and what that'll do is it'll get the denominators to wipe out. So if I multiply the first part here, the first terms, by 2x, I'm doing 2x times 2x is 4x squared. And then we have plus, I do 2x times 5 over 2. And for this part here, the 2's are going to cancel out. And now this is equal to, we have 2x multiplying to 3 over x. So we have 2x, and we're multiplying by 3 over x. And then here, the x's are going to cancel out like this. So then for the next stage here, we have coming up on, this part over here, 4x squared. And then plus, we have x times 5 is 5x. And this is all equal to 2 times 3 is 6. One thing I want to point out is that there was an x in the denominator in the beginning. So I should say that x cannot be 0. So if 0 somehow pops out of this, we have to reject that solution. So now I'm going to go minus 6 on both sides. And what we have is we have 4x squared plus 5x, and then minus 6 equals 0. So now from here, we would use the AC method. So we're looking for two numbers that have a product equal to, and we're talking about when we have something in the form of ax squared plus bx plus c equals 0. The AC term is the product of the number in front of the x squared and the constant at the end. So our AC term here is 4 times negative 6, which is negative 24. And then the b value would be equal to 5. So then to use the AC method, we're looking for two numbers that have a product of negative 24 and a sum of 5. And that would be 8 and negative 3. So then what we do is we rewrite the middle term here as 4x squared. And then we have plus 8x minus 3x and then minus 6 equals 0. And now we could factor by grouping. So we're going to take out the greatest common factor here is 4x. And then we have x plus 2. And then we take out a minus 3 and we're left with x plus 2. And this is all equal to 0. So we'll just shrink this down for space. And now I'm going to factor out the x plus 2. And we're left with 4x minus 3 in the second set of parentheses. So now from here, notice that when we find the roots here, the factor x plus 2 is going to give us a root of x equals negative 2. And if I set 4x minus 3 equal to 0, this is going to give us a root of x equals 3/4. And notice that this matches exactly what we have here at choice 2. But remember, in the beginning, you could just use logic and say choice 2, or tracing the intersection points would probably be your best bet. Question 5, given f of x and g of x, the quotient of f of x over g of x is, and for this one, we could use synthetic division. So we are going to be dividing here. We have 2x to the third minus 3x squared minus 5x minus 12, and we're dividing this by x minus 3. So with synthetic division, what you do is you write the coefficients of the polynomial on the inside. So we have a 2x to the third, a minus 3x squared, a minus 5x, and then a minus 12. So I just write the coefficients. If let's say I didn't have an x term, then I would put a 0 over here in place of the negative 5. And then what you do is the factor, what you want to think about is the corresponding root. So the factor that we're dividing by is x minus 3. So I think of when is x minus 3 equal to 0? It's equal to 0 when x equals 3. So that's the number that's going on the outside like this. And now we start the process. We carry down the 2, and we do 3 times 2 is 6, and then we add negative 3 plus 6 is positive 3. Then we do 3 times 3 is 9, and then 9 minus 5, or negative 5 plus 9 is 4. And then we have 3 times 4 is 12, and negative 12 plus 12 is 0. So this tells us that we have no remainder, and when we actually do the division here, what we're going to wind up with is we're going to have 2x to the second power, and then we have plus 3x, and then we have plus 4 at the end. Okay, so this is going to divide nicely here, nice and even. And let's scan the answer choices. This is going to match up with choice 1. But for something like this, we could also just type this right in the calculator. So if we type in the quotient here, we press alpha y equals enter, and we could write in, we have 2x to the third power. So we have this, and then minus 3x squared. We have minus 5x, and then minus 12. And we're dividing this by, we have x minus 3. And then I'm going to type in the correct answer here. So we have 2x to the second. We have plus 3x, and then plus 4. And notice that when we graph the both of these, that the graphs overlap completely. Okay, so that's how I know choice 1 is correct. If I type in one of the wrong answers, it's not going to overlap with the original graph that we had in blue here. So that's how I know 1 is definitely good. Question 6, Abby is told that each day there is a 50% chance it will rain. Which simulation could Abby perform to determine the likelihood of it raining for the next 7 days? So for this one, let's see with choice 1. We have flip a coin 7 times, count how many heads, and repeat 50 times. So this one right away is looking good because what we have here, we have that Abby is told there's a 50% chance it will rain. Well, if we flip a coin and we count how many heads, there's a 50% chance of getting heads when you flip a coin. Okay, so right now the probabilities are matching. And then they're saying here that we're looking for a simulation to perform to determine the likelihood of it raining for the next 7 days. Okay, and notice that they're saying Abby could flip the coin 7 times. So these events here are matching up as well. And then if the goal is to perform a simulation, notice the simulation part is matching up with repeating it 50 times. So choice 1 is looking good right away. Now let's see why the other answer choices are no good. So if we look at the other answer choices here, roll a die 7 times. This one is no good because the die, so the die, if we roll a cube like this and it has 1 through 6, going all around. So it could be like, let's say 1 here and then like 2 here and then 3 and so on. The die, there's a 1 out of 6 chance of rolling a 2. Okay, so yes, this does count as a simulation, but the probability doesn't match the probability of rain. So that's why this one is out. And now for choice 3, if we roll a pair of dice and we count the totals of 7, this one here, looking at the possibilities of rolling a 7, it's not going to be exactly 50%. So right away, the 50% is not upheld. So that's why this one is also out. And then choice 4, let's see, we have flip a coin 50 times. So if we flip a coin 50 times and we count how many heads, this is not matching up with the condition here of looking for the likelihood of it raining for the next 7 days. Okay, so this one here is almost behaving like the simulation in choice 1, except for the fact that the coin is not being flipped 7 times. So this would be if we're just looking at the likelihood of it raining, like, over like the next day or something, and just looking at 1 day. So that's why 4 is out, and it's definitely choice 1. Question 7, what are the solutions to 4x squared minus 7x minus 2 equals negative 10? So for this one, we want to use the quadratic formula, and we want to make sure that our quadratic is in the form of ax squared plus bx plus c equals 0. So the first thing I'm going to do here is just add 10 to both sides. That way our quadratic equation is in the form it needs to be. So we're going to have over here 4x squared minus 7x, and then negative 2 plus 10 is going to give us positive 8. And this is all equal to 0. So now we could use the quadratic formula, which is x equals, we have negative b plus or minus the square root of b squared minus 4ac, and this is all over 2a. So now we could plug right into this formula here. We're going to have x equals, and we've got negative b is going to give us positive 7, and then we have plus or minus the square root of, in parentheses, I'm going to write negative 7 squared, and then we have minus 4 times 8. And this is all over 2 times a, and a is equal to 4. Just know that if you are typing this part in the calculator, please make sure that you put the negative 7 in parentheses. Otherwise, the calculator is going to give you something different. Okay, so now we could simplify. We have x equals, and we have 7 plus or minus. And now on the inside here, we're going to have 49. So I'll write that over here. We're going to have 49. And then minus, if I do 16 times 8, that's going to give us 128. Okay, so we're going to have 128 over here. And now we just subtract these two. And we're going to have 49 minus 128 is minus 79. And this is all over 8. So now we're getting closer. And the thing to know next is that the square root of negative 1 is equal to I, where I is the imaginary number. So from here, I'm looking at this square root of negative 79. And I just want to rewrite that as we have x equals 7 plus or minus, and we have I square root of 79. So we could just take that negative out as the term I here. And now I'll write out the final answer, and I'll write it out over here. So I'm just going to draw the arrow over here. We're going to have x equals, and we're going to have 7 over 8. So we're just going to divide each term by 8 now. And then plus or minus, we have square root of 79 over 8, and then times I. And this matches up with choice 2. So now let's check our answers. So if you're going to check your answer to a question like this, you have to go to mode and switch from real to imaginary, or we could say here a plus bi. This allows us to type in complex numbers. And now I'll write in, we have alpha y equals enter, 7 over 8. And then the rest here we have plus or minus, but I'm just going to write plus first. And then we have alpha y equals enter, we have square root of, so second x squared. We have 79 on the inside, and then 8 in the denominator. We have the right arrow, and hit second decimal to pull up the I. I press enter, and then I'm going to store this. I'm going to press store alpha math, and I'm going to store this as the letter A. And now what I could do from here is I could type this into the original. I could do 4 times, I have alpha math, and I have this squared, and then minus 7 times alpha math, and then minus 2, and that should work out to negative 10. And it does. It comes up as negative 10 plus 0i, which if the imaginary part is 0, then we just look at the real part here. So choice 2 is looking good. Question 8, if x minus 5 is a factor of p of x, then which statement must be true? So for this one, we're using the polynomial remainder theorem, which tells us that there's an opposite relationship between factors and roots. So when I hear that x minus 5 is a factor, this tells us that x equals 5 is a root of p of x. Okay, so this is a root of p of x, which then tells us that if we plug 5 into the function, we're going to get 0. So p of 5 has to equal 0, and then we can see right away that choice 3 is our answer. Question 9, in a small city, there are 22 gas stations. The mean price for a gallon of regular gas was $2.12 with the standard deviation of 5 cents. The distribution of the data was approximately normal. And then we have, given this information, the middle 95% of the gas stations in this small city likely charge, and we have these 4 options to choose from. Now, the moment you hear the phrase approximately normal, this means that our graph of the situation is going to be a normal bell curve like this. Okay, so this is the concept behind the question. When they tell you to find the range of the middle 95%, what they're telling you to look at is plus or minus 2 standard deviations from the average or the mean. So now to see this concept, we look at the mean price. The mean price is $2.12, and that's telling us what's going on exactly at the center here. And this is representing the 0 line here when we're 0 standard deviations away because we're right at the average. If I go forward 2 standard deviations, I'm going this way. And if I go backwards 2 standard deviations, I'm going left into the negatives here. So the concept behind what is the middle 95%, that's talking about the space under the graph. So this is, in a way, highlighting the 95% of the area under the graph to this horizontal line here. So our goal is to find what is the range of price. So here, what we could do is we take the standard deviation and we multiply it by 2. Okay, so I'm going to do 2 times the standard deviation. So I have 2 times 0.05. And from here, we're going to get 0.10. And with this value here, we're going to add and subtract it to the average. So I have the average here is 2.12. I'm going to do 2.12 minus 0.10. And this gives us 2.02. Now, right away, I could see that this matches up with choice 3. But I'm just going to see what happens when I add the standard deviation times 2 to the average price. So I have 2.12, and I'm going to add 2 standard deviations this time. So I go like this, and notice that we get 2.22. Okay, so this is definitely matching up with choice 3. If I throw these values on the graph, notice at 2 over here, I would have 2.22, and over at negative 2, I would have 2.02. So this represents the prices. Since 1 standard deviation was just 5 cents, if I add 5 cents to 2.12, I would have 2.17. And if I subtract 5 cents, I would have 2.07. And this would tell us the range of values from plus or minus 1 standard deviation. So this answer choice over here is a very dangerous bear trap, okay? Just make sure you're very careful here and make sure that you're finding plus or minus 2 standard deviations. Question 10, the expression here is equivalent to, and for this one, we could use polynomial division. So we have 4x squared minus 5, and we're dividing this by x squared minus 1. If you want, you can use a placeholder for the missing x term. There is no x term, so I could say plus 0x and then minus 5 like this. But when we're dividing, we don't actually have to write the placeholder for this part that we're dividing here. It's fine to just leave it as is. And then from here, we start the process. We're going to divide the leading terms. So I'm going to do 4x squared divided by x squared. And if we divide these two, we get 4. And now I multiply across. I do 4 times x squared is 4x squared. And I do 4 times negative 1 is going to give us negative 4. So in this case here, the placeholder is not really necessary, but there are some examples where the placeholder could be very helpful. So I have 4 times minus 1, and that gives us minus 4. So then from here, we're going to subtract these two. The most common mistake here is that students, when they subtract, they don't change the signs of everything. Because when I subtract this entire thing here, the minus goes through, and that's going to make a minus 4x squared, but it's going to make a plus 4 at the end. So one thing you could just do is just change the sign of everything like this, and then just add the terms. So now we combine everything here, and we have 4x squared minus 4x squared canceling. And then we have minus 5 plus 4 is minus 1. So the minus 1 is our remainder, but it's over the original divisor, which was x squared minus 1. So we're looking for this answer choice here, and this matches up with choice 1. Now, one last thing before we move on. This method here is just pure sorcery, okay? So this one here is really unusual and probably not the most reliable method, but it is fun to use once in a while. So here what I notice is if I multiply the denominator by 4, I get 4x squared and then minus 4. And then I look at the top and I'm like, oh wow, this is almost equal to 4x squared minus 4, except it's just off by 1. So then I rewrite the top as 4x squared minus 4 and then minus 1. So all I'm doing here is I'm just rewriting the minus 5 as minus 4 minus 1. And there's a point to this. You'll see why I'm doing this in a moment. And then we're dividing by x squared minus 1. But then what I'm going to do is I'm going to break this fraction up into two fractions, where the first fraction is going to have a numerator of 4x squared minus 4, and the second fraction will have a numerator of minus 1. So now we're going to say here this equals, and we have 4x squared minus 4, and we're dividing by x squared minus 1. And then next we're going to have minus 1 over x squared minus 1. But if you pay attention to the purple part here, if we rewrite that part, we're going to have in purple, we have 4 times x squared minus 1, and we're dividing by x squared minus 1. And then in pink here, we have minus 1 over x squared minus 1. And notice that the matching factors here cancel out nicely. And what are we left with? We're left with 4 and then minus 1 over x squared minus 1. So we get the exact same answer. And it's up to you to decide which one you think is better. But once again, this you cannot use all the time. It just pops up once in a while. And I think it's just a fun method to see. Choice 1 is our answer. Question 11, for all positive values of x, which expression is equivalent to? And we have square root x times the fourth root of x to the 11. So for this one, we need to know two main rules. We need to know that when we have something like a to the b over c, this is equal to the c root of a to the b power. And also we need to know that when we multiply exponents that have the same base, we just add the exponents together like this. Okay, so the first thing I want to do is use that first rule, but I'm actually going to be using this rule backwards. And another small detail is when there's no exponent written above x, there's an invisible 1 there. And when there's no root written in front, it's always square root, which is a root of 2. So when I rewrite this in a moment, this part over here, I'm going to say, and we'll just make this a little neater, so put this over here, that the first part here is actually going to be equal to x to the 1 over 2. I'm doing the power, so just note over here, it's power over root. Okay, so just say that to yourself a few times, power over root. So I have x to the power 1 over the root 2, and I'm going to be multiplying here by x to the power 11 over the root 4. So now that I have this written in power over root form as a rational exponent, now I could use that second property over here and just add those numbers together. So we have x to the 1/2 plus 11 over 4. And for this, you could use the calculator, or you could just make common denominators. You could say 2 over 4 plus 11 over 4. So now that we turn this into a nice fraction with a matching denominator, we could add these. 2 plus 11 is 13, and the denominator stays the same. So this is going to give us x to the 13 over 4, which tells us that choice 3 is our answer. But for something like this, I could just use the calculator again. So I could write, we have square root of x, and then I hit the right arrow to get out. I'm going to write times here, because if I write the next radical, it's going to mess up what we have in front. And I'm going to press math, and then number 5 is a custom radical. So I have square root x times the fourth root of, I hit the right arrow, and we have x to the 11th power. So I have x to the power 11 like this. And then I look at all the answer choices. I go one by one, and then I finally type in x to the power 13 over 4. And if I press graph here, notice that I get exact matches here. So that's how I know that choice 3 is good. But if we want to see it with the rules, we can do this algebraically. Question 12, the expression I squared times 5x minus 2i squared is equivalent to, and we have these 4 options to choose from. So for this one, it helps to know the powers of I. We have I to the 0 is 1. We have I to the first is equal to I. But then we have I squared is equal to negative 1. And if I do I to the third power, I just multiply both sides by I get I to the third is negative I. But then the moment I go to I to the fourth, this is going to give us, it's going to bring us right back to positive 1 over here, okay? It's going to go back. And the way to see it, if you multiply both sides by I, you get minus I squared, but we said that I squared is negative 1, so we get minus 1 is positive 1. So the pattern repeats every 4. So this is just helpful to have for a question like this. So right away what I'm seeing is we have I squared. That piece I could just replace with negative 1. But then this stuff over here, we have 5x minus 2i squared. We're doing 5x minus 2i, and we're multiplying that by 5x minus 2i. So I'm just going to expand this out. So we're going to have negative 1. And then when I expand this part, so I'm going to write this over here, we're going to have 5x times 5x is 25x squared. And then we have 5x times minus 2i. We do 5 times negative 2 is negative 10. We have an I, and then we have an x right after. And then for the next part here, we have 2i times, negative 2i times 5x is minus 10ix again. And then we have minus 2i times minus 2i is plus 4i squared. But this is where the powers of I come in. The I squared, I'm going to replace with negative 1 in the next line. And it looks like for all these answer choices that the I is written after the x. So I will make that adjustment at the end. So here, we're going to have negative 1. And we're multiplying this by, we'll simplify things a bit. We have 25x squared. And then here we have minus 10ix minus 10ix. So that's minus 20. And this time I'm going to write the x in front and then the I so it matches the answer choices. And then at the end, remember, I squared is equal to negative 1. So when I do 4 times negative 1, I get minus 4. And then we close the parentheses. And now I could distribute the negative 1 in front. So I go minus 1 times this is going to give us, we're going to have minus 25x squared. And then minus 1 times this gives us plus 20xi. And then multiplying by negative 1 again gives us a plus 4 at the end. Okay, so this is what we're looking for in the answer choices. And let's see, these two are out. And if we look, it's going to match up here with choice 2. There's our answer. Question 13, functions f and g are given below. And then we have when 2 f of x is subtracted from g of x, the result is, and we have these 4 options to choose from. So we just have to make sure we set this up very carefully. Let's just color code here. We'll say f of x is in purple, and we'll put g of x in pink. So what we're doing is we are subtracting 2 times f of x from g of x. So g of x is going first, okay? We're going to have g of x, and we are going to subtract 2 times f of x. Okay, so that's the order in which we have to place these functions here. So remember, the phrase subtracted from means things are going to be flipped. So that's just a very sneaky detail to look out for. So now let's plug in g of x is 3x squared minus 7x plus 25. And here we're subtracting 2 times f of x. But just make sure to write f of x in parentheses here so that you don't forget to distribute the negative. So we have 7 over 2 times x squared, and then we have minus 5x, and then plus 11. So now for the rest of this question, what I would do is I would write the results vertically so that it's easier to combine like terms. So we're going to have next 3x squared minus 7x plus 25. But now let's think. When we multiply the first part here by negative 2, I'm just thinking in my head of how to multiply the whole number in the fraction. So we have negative, and then we're doing 2 times 7 over 2. But when we multiply, 2 over 2 is going to cancel, just giving us 7. So we're going to have a negative times a positive is negative. So I have minus, and then I'm left with 7 and then x squared. Okay, so once again, just remember, 2 over 2 cancels. We're left with a coefficient of 7, but the x term here is x squared. And then we do negative 2 times negative 5 is positive 10, and there's an x attached, so we just tack on the x. And then we have minus 2 times 11 is minus 22. And once again, I like to write this vertically so that it's easier to combine like terms. So now we have 25 minus 22 is positive 3. And then we have negative 7 plus 10 is plus 3, but there's an x attached. And then we have 3 minus 7 is minus 4, and there's an x squared attached. So now we just go scanning, and this is going to match up with choice 2. Question 14, a manufacturer claims that the number of ounces of a beverage dispensed by one of its automatic dispensers is normally distributed with a mean of 8 ounces and a standard deviation of 0.04 ounces. To the nearest tenth of a percent, what percent of the cups filled by this company's dispenser will contain between 7.9 and 8.11 ounces? So for this one here, what we have to look for is the important information to type into the calculator. So we have to know what the mean is. And here we have a mean of 8 ounces. And then we need to know the standard deviation, which is 0.04 ounces. And then next we have to know what the range is. And we're going from 7.9 to 8.11. And then we just type all of this into the calculator. So we could go back to the main screen here. We press second mode to get out of this. I'll just clear this out and we're going to press second and then vars. And we're going to go to normal CDF. Okay, so option 2. And then for the lower, that's the lower bound here of the interval. So that's going to be 7.9. And then for the upper bound, that's 8.11. And then next we have the average is 8 ounces. And the standard deviation is 0.04. And basically we just type all of this into the calculator and it's going to give us the percent in one shot. So we just type all this in, we press enter, and this gives us the decimal value. But if I multiply by 100, this is going to give us the percent, and we're rounding to the nearest tenth. So notice in the tenths place we have a 0, to the right is an 8. So we would round up to 99.1. Choice 3 is our answer. Question 15, what is the value of x in the solution of the system of equations below? So for this one, what I'm going to do first is just label these equations. We have equation 1, equation 2, and equation 3. And what I look for is terms that'll cancel out nicely between both equations. So I'm looking at equation 1 and equation 3, and I notice that the x terms, the coefficients are matching opposites. So I'm going to write the equations over here. So we're going to have 5x plus 2y minus z is equal to negative 14. And then I'm going to write the third equation, but I'm going to write it in order x, y, z. So we have minus 5x, and then we have a 5y, we have a 4z, and it's all equal to minus 23. So now I'll add these, and we could just combine like terms now. So these terms cancel. We have 2 plus 5 is 7, and we tack on the y. Minus z plus 4z is plus 3, and we tack on the z, and then this gives us negative 37. Okay, and then from here we have this nice equation, and we could use this equation with equation 2 now to eliminate the variable z. So what I'm going to write just underneath it here, I'm going to put right underneath this, I'm going to put 3 times equation 2. Okay, so 3 times equation 2, I'm going to write over here. And if I multiply everything here by 3, I get 21y. I get 3 times negative z is minus 3z. And then I get 3 times 31 is going to give us 93. Okay, so I just try to just eliminate variables one at a time here. And notice now when I add these, the z terms cancel. I get 28y is equal to, and now when I subtract these two, I get 93 minus 37 is 56. Or I could just think here, negative 37 plus 93. I could just type that in a calculator and I'll still get 56. So now what this tells us, it tells us here that after we divide both sides by 28, that y is equal to 2. Okay, so y is going to be equal to 2. But the question is not asking us for the y value. They want to know what is the value of x. But now that we have one of the variables, we could use this to solve for the other ones. So let's say I take equation 2 now. I could take equation 2 and I have 7 times y, which is equal to 2, minus z is equal to 31. And now just work this out. 14 minus z is equal to 31. I subtract 14 on both sides. And now we're going to have here that minus z is equal to, and this gives us 17. So z would be equal to negative 17 after I multiply both sides by negative 1. Okay, so I could just multiply both sides by negative 1, and I get this. So now we're almost there. We could get the x value just by plugging in. And let's say I plug into the first equation here. So I'm going to go back to equation 1, and let's change colors here. So I'm going to go back to equation 1, and I'm going to plug in, we have 5x, which is what we're looking for, the x term, plus 2 times y is equal to 2, minus z is equal to negative 17, and this all should make negative 14. So now we have 5x, and then we have over here, this is going to give us 4 plus 17, which is going to give us 21. Okay, so we do 4 plus 17 is 21, and this equals negative 14. And now we just go minus 21 on both sides. So then next, these terms cancel. And now we have 5x equals negative 14 minus 21 is negative 35. And then divide both sides by 5, and this tells us that x is equal to negative 7. So choice 4 is our answer. If for some reason you have a calculator that could do this, you could press apps, go to number 9 here, and then you go to simultaneous equation solver number 2. And then from here, we have a 3 by 3 system. We have 3 equations and we have 3 unknown variables. So we type this in, we press graph to go next. And then I have to just type this in. I have 5x, so I press 5, enter, enter, because I have a plus sign. And then I have 2, so I press 2, enter, y, and then we have minus z. So here I could write minus with the subtraction sign like this, and then type in 1 for z. I could also do plus -1 times z. Either way, I'm going to get the same thing at the end. And then I have minus 14 after the equal sign. And then next we have 0x, because it's just starting at the y. So I press enter just to continue here. And then we have 7y. And then we have minus z, so minus 1z. And this is equal to 31. And then last, we have a minus 5x. Notice this one's out of order, so it's a little bit tricky to deal with. We have a plus 5y. And then we have a plus 4z. And all of this is equal to negative 23. So we type all of this in, we press graph to solve, and notice we have x equals negative 7, which is what we got, y equals 2, and we have z equals negative 17, so our values check out. Question 16, the graph below shows the amount of radioactive substance left over time. And we have this graph over here. And then we have next, the daily rate of decay over an 8-day interval is approximately, and then we have these percentages here. So the concept for this question here is we have an exponential function and we need to find the base of our exponent. So I'm noticing over here that we have the point 0, 50 is on our graph. And then the next best point we could find is over here when we have x equals 2, we have a y value here of 30. Okay, so we have 2, 30 is another point on our graph. And notice that I'm finding this out because the space from 25 to 50 is 5. So they're counting by 5s here. We have 25, 30, then we have 35, 40, and then we have 45, and then 50. I could use some of the other values here, but this one looks to be the most precise. So now we could just go to the main screen here. We could press stats, edit, and I'm going to type in, we have 0, 50. So I'm going to put that as my first point here. And then the second point we have is 2 and then 30. And since we're dealing with exponential decay, I'm going to use, we have stats, calculate, and then exponential regression is over here at 0. Okay, so I'm just going to type that one in and calculate. And this is going to give us the values we need to answer the question. So if we write out our equation now, we have y equals, the a value is 50. And then the base of our exponent, if we round to the nearest hundredth, is 0.77. And now we're raising this up to the x power. So we scan the answer choices here, but we just have to be very careful of choice 4. Choice 4 is a very dangerous bear trap. One thing you want to be mindful of, you want to think of this formula from Algebra 1, which still shows up every now and then in Algebra 2. But when we have a equals p times 1 plus or minus r to the t power. So the rate here, when you're dealing with decay, the rate is the amount being subtracted from 1. So here we're dealing with a situation where we have a equals p times 1 minus r to the t power. So I'm noticing that the base of our exponent is 0.77. So we could say that 1 minus r is equal to 0.77, and then the mystery value for r would actually be 0.23. And this would be the rate of decay that we're looking at, and this is equal to 23 over 100, which is equal to 23%. Okay, so the rate of decay here is actually going to be choice 1. Question 17, if 4 times 10 to the 5x minus 2 equals 12, then x equals, and we have these 4 options to choose from. So for something like this, what I would do is I would try to get the exponential term by itself first. So notice that we have a 4 attached by multiplication to the exponential term. So I would just divide by 4 first to just clean this up a little bit. So 4 over 4 cancels. And now in the next line, we're going to have 10 to the 5x minus 2 is equal to 12 divided by 4 is equal to 3. And then the next idea that we need for this question is that when we have something like log base a of a to the b power, this is just equal to b, okay? Because log base a and a to a power are opposite operations. So in a sense, they just cancel out and just gives us this value here. So that's the idea that I want to use for the next part. So I'm going to take the log of both sides. And just know that when you take the log of both sides like this, and there's no actual base written there, the invisible base is 10. Okay, so the standard log like this, the invisible base is 10, but we don't actually have to write it unless the only time we have to write the base is when it's something other than 10. So just that's something to be mindful of in this question here. Okay, so this is equal to, and I'm taking the log of the right side as well. So we have log 3 like this. And now at this step, if you just recognize that the base of this log matches the base of the exponent, that they'll just cancel, then great. Otherwise, what you could do is you could use the exponent property of logs. So anytime I have an exponent inside of my log like this, I could bring it out to the front of the log like this. So I would have 5x minus 2 times log of 10. And now this is equal to log of 3. And this, once again, I could just use the idea that when I have log base 10 of 10 to the first, that this is just going to be equal to 1. Or if that idea is not familiar, you could just type log 10 in the calculator and you're also going to get 1. Okay, the other way to evaluate that kind of stuff in your head, when I'm looking at this stuff over here, so I'll just highlight this in, let's say, green. So this value here, what I do is I look for the mystery power. I ask myself, 10 is the base of the log to the blank power is equal to 10, and the mystery value would be 1. So that's how I know this value over here is equal to 1. Okay, but otherwise, once again, you could just use a calculator for something like this, and this term just basically just wipes out. So I get 5x minus 2 is equal to log 3. So now to solve for x, I just go plus 2 on both sides. And please, whatever you do, do not do log 5. Do not add these numbers, just leave them separate. So we're going to have 5x is equal to, and I'll write it like it shows up in the answer choices. I'll put the 3 in parentheses, just so we see that this is connected to this log, and then plus 2. And then to solve for x, we just divide both sides by 5. And this tells us that x is equal to log of 3 plus 2 over 5. Choice 3 is our answer. But remember, the calculator can save you for a question like this. All right, the calculator is very useful in the multiple choice if you don't know how to do the algebra. So I could just type in the left side of the equation here. So I have 4 and then parentheses 10 to the power, and I have 5x minus 2. And then I hit the right arrow to get out, and I close the parentheses, and now this is just equal to 12. But what's going to happen is I press graph, and I'm like, oh no, I don't see anything. And that's because I graphed the line y equals 12. So I'd go to the window and bump the y maximum up to 20 like this. And now I could see the point of intersection. I press second trace number 5 to get the intersection, and I go nearby. So I'm going to press enter 3 times, and it gives me this value here. I hit second mode to quit, and then second minus sign to put the answer here. And then I would just have to go through the answer choices one by one. I press alpha y equals enter, and watch what happens when I type in choice 3. So I have log 3, I close the parentheses, and then plus 2, and we're dividing this by 5. And I get the exact same value here, so our answer checks out. Question 18, a random sample of 152 students was surveyed on a particular day about how they got to school. The survey results are summarized in the table below, and we want to know which statement is best supported by the data. So notice that all the answer choices start off saying the probability of being late given that the student walked. So let's go ahead and find that, and I'll use the notation. I'll say the probability of being late, so the probability of being late, and then we'll say given that the student walked. And when we're finding this probability, the probability of being late given that the student walked, that means we have to restrict the information to just this space over here. Okay, so we're just going to be looking at this row. We're saying given that the student walked, so we're only looking at these values here. And notice that the number of people that walked when they were late was 4, and then we just have to divide by the total here. The total number of people in this category of people who walked is 4 plus 18, which gives us 22. So that's what we're dividing by over here. And now let's focus on the other probability. The probability, so I'll just color code this, the probability of being late given that the student walked. And now we're going to look at the probability that the student walked given that the student was late. Okay, and I'll just write that over here. The probability that the student walked given that they were late. And for this one, the restriction is on being late. So we're going to be focusing on this column over here. And now we just look for the number of people that walked in this space over here is 4. And now we're dividing by, we're doing 6 plus 20 plus 4 is 30. Okay, and when I compare these two values, I could type them in the calculator, but if you just think about it, the numerators are equal, but the denominators are different. If you have the same numerator, then the fraction with the bigger denominator is smaller. Okay, so this fraction here is going to be smaller than the fraction above. Just think of a pizza. If you had 4 slices of pizza and there were 22 slices in the pie, and then this pizza had 30 slices, then the 4 slices here are smaller. Okay, so this one here is the greater amount. And now we look back to the answer choices here, and let's see that the probability of being late, given that the student walked, is greater than the probability that a student walked given that the student was late. So right away, this is our correct answer choice. This one is no good because they're saying it's less, but the blue stuff is greater. And then for choice 3, they're saying equal, but these values here are not equal. And then they're saying the probability cannot be determined, but we can determine it. 4 is out, definitely choice 1. Question 19, if f of x equals the cube root of x plus 4, then f inverse equals. And when you're solving questions like this, what you want to do is 2 steps. You want to switch x and y, and then next you're going to solve for y. Okay, so these are the 2 steps for finding the inverse of a function. Another thing to think about here is just know in general, we say y equals f of x. So here, when I'm looking at this original equation here, I'm thinking y equals cube root of x and then plus 4. So when I have to switch x and y, when my function just says f of x equals, I just imagine it says y equals and then cube root of x plus 4. So now when I have to do the first step, I switch x and y, I'm going to say x equals cube root of y and then plus 4. And then the next step is to solve for y. So I'm just focusing on this term here. This is what I want to get by itself. So we could start by going minus 4 on both sides. And now on the right side, 4 minus 4 cancels. We have x minus 4 equals the cube root of y. And now the last step here, the opposite of taking the cube root is raising something to the 3rd power. So we raise both sides to the 3rd power like this. And then this will tell us that y is equal to, we have x minus 4 to the 3rd. And if I wanted to answer this formally here, the inverse function, I could write it out like this. I could say f inverse of x is equal to x minus 4 to the 3rd power. So choice 2 is our answer. Question 20, given the equation s of x equals 1.7 times sine of bx plus 12, where the period of s of x is 12, what is the value of b? So for these types of questions, what we should know, and I'll write it in terms of sine, is we should know the general equation for a sine curve. And this also works for cosine as well. So when I have something like this, what the value a tells me is my amplitude. Okay, so this is the amplitude. The b value is the frequency. And the frequency just means how many complete cycles of the wave. So a complete cycle looks something like this. It starts from a certain position, it goes all the way up, all the way back down, and back to where it started. So the frequency tells you how many of these cycles are completed from 0 to 2 pi, or in the space of 2 pi. And then the last value here, the c value, is the midline, okay, which basically just tells you like this part of the graph over here that just cuts it at this location. So another detail to know is that there is a unique relationship between the frequency and the period. So just know that the period, I could say, is equal to 2 pi divided by the frequency. But I could also swap these and say that the frequency is equal to 2 pi divided by the period. Okay, so this is where my head goes with these questions right away. I think about the anatomy of the equation, and when they're asking us here, what is the value of b? B represents the frequency in this case because it's the coefficient of x. So what I'm going to say here, I'm going to say that the frequency is equal to, we have 2 pi divided by the period, and they told us the period of our function is 12. So I just do 2 pi divided by 12, and if I divide the top and bottom by 2, this reduces to pi over 6. So choice 1 is our answer. Question 21, Jin solved the equation square root of 4 minus x equals x plus 8 by squaring both sides. What extraneous solution did he find? So for this one here, I would just start off by going through the math. So we have the square root of 4 minus x, and now this is equal to x plus 8. And we're going to do what Jin did. We're going to square both sides. Okay, so we're going to square the left side, and we're going to square the right side. On the left side, the square root is going to cancel out with the square, and we're going to get 4 minus x equals, and now on the right side, just be careful. Make sure you do x plus 8 times x plus 8 like this. And then the result, I'll write over here, we're going to have 4 minus x is equal to, we have x squared, and then we have plus 8x, and then we have plus another 8x, and then we have plus 64. Okay, so then this, now we could simplify. We have 4 minus x equals x squared plus 16x, and then plus 64. And now we could go plus x on both sides, and we could go minus 4 on both sides. So we're going to solve this equation the same way that Jin did. We start by squaring both sides. And now we have 0 equals x squared. 16x plus 1x is 17x. And then 64 minus 4 is 60. And now from here, we need two numbers that have a sum of 17. And we need the two numbers that have a product of 60. And the mystery numbers are 12 and 5. Okay, so x plus 12 times x plus 5. And 12 plus 5 is 17. 12 times 5 is 60. So the two roots here are x equals negative 12 and x equals negative 5. But we need the extraneous one. So these answer choices are out because neither of them match what we have over here. But let's see what happens when we plug in. Let's say we plug in x equals negative 12. So I'll just make some space over here. I'm just going to move this over. So let's see. We're going to plug in first. We're going to plug in x equals negative 12. And if I do this, so I'm plugging in the first one, I'm going to have the square root of, and I have 4 minus negative 12 equals, and now I have negative 12 plus 8. And right away I could see that this one is no good because I get the square root of 16 equals negative 4. But the square root of 16 is equal to positive 4. Your square roots are always going to send out positives here. So that's how I know this one is no good. That's the extraneous solution that if we were solving this the long way, we would reject. So then that tells us x equals negative 5 should work. And if we plug it in, we're going to get square root of 4 minus negative 5 equals, and now we have negative 5 plus 8. And this gives us the square root of 9 is equal to 3, which is a true statement here. So that's why it's out. We need the extraneous one, which is the one that we reject. Question 22, the expression x squared plus y squared squared is not equivalent to, and we have these four options to choose from. So first, I'm going to expand the original expression. So I'm going to do x squared plus y squared times x squared plus y squared. Okay, just make sure for this that you don't do something like x squared squared plus y squared squared. Don't forget the middle stuff, but that's a very common mistake. So let's just see what we get. So we have x squared times x squared is x to the fourth. But then we get x squared times y squared is x squared y squared. And then for the other middle stuff here, we have y squared times x squared is another x squared y squared. And then we have plus y squared times y squared is y to the fourth. And this will simplify to, we have x to the fourth plus 2x squared y squared, and then plus y to the fourth. So we could go through choice 1 first. So let's see what happens when we expand choice 1. So if we expand choice 1, we're going to have x squared minus y squared times x squared minus y squared. And then we're going to have plus, we're doing 2xy times itself. So this one I'll do a little bit faster. We're going to have x to the fourth, and we are going to have a plus y to the fourth at the end. But this time around, we would have, in the middle, we have a minus x squared y squared and another minus x squared y squared. So we have minus 2x squared y squared. But then at the end, we have this stuff over here. We have plus 2 times 2 is 4, and then x squared y squared. So when we combine these two over here, the x squared y squared terms, this simplifies to x to the fourth. Negative 2 plus 4 is positive 2, and we have x squared y squared, and then we have that plus y to the fourth at the end. So this one actually does match. We want the one that's not equivalent to. So that tells us choice 1 is out. So now let's look at the remaining answer choices. And for choice 2, to expand x plus y to the fourth, that's going to be really tedious to do. So what I'm going to do is I'm going to use Pascal's triangle. So if you don't know how Pascal's triangle works, we start off with a triangular array of ones. And then I just keep putting ones down like this along the diagonal, going towards this direction and this one. But then to get the middle stuff, I'm doing 1 plus 1 is 2. And then over here, I'm going to do 1 plus 2 is 3. And I do 2 plus 1 is also 3. If I had to continue this, I put another 1 and I do 1 plus 3 is 4. And then 3 plus 3 is 6. 3 plus 1 is 4. And then the 1 goes along the diagonal. And what this tells us is if I have something like x plus y to the first, this would simplify to x to the first plus y to the first. And my coefficients would be 1 and 1. So these tell you the coefficients of your x and y. If I had something like x plus y to the second, how this is going to go is I'm going to have x squared terms. I'm going to have an xy term because my x is going to drop down a power to the power 1. My y is going to come up as a power 1, and then I'm going to end with y to the second. And then this tells me my coefficients are 1x squared, and then plus 2xy, and then plus 1y squared at the end. Okay, so these tell you the coefficients. If I had to do x plus y to the third power, using Pascal's triangle, it would be 1x to the third, and then I would have a 3, and I would have an x squared y. I just bring my x down by a power of 1, and I bump my y up a power of 1. And then my next coefficient is 3. I bring my x down 1 power, and my y up 1 power, and then my last term would be y to the third. So now for the next one here, we would have x plus y to the fourth power is equal to x to the fourth, and then plus we have a coefficient of 4, and then our power of x goes down 1, and our power of y goes up 1. And now we would have plus, our next coefficient is 6, the x power goes down 1 to x to the second, the y1 increases to y to the second, and then the next coefficient is 4, and then the x power goes down, the y power goes up, and then finally the last coefficient is 1, and we have y to the fourth power. So this is just a nice little shortcut to get here, but this tells us right away that choice 2 is out, because look how complicated this piece is over here. And this extra term that we're adding here, it is not going to simplify nicely to x to the fourth plus y to the fourth, and then just a 2x squared y squared in the middle. Notice that we have all this extra stuff over here and over here. So that's how I know choice 2 is going to be our answer, because that's definitely the one that doesn't match. But just as an exercise, if you want to expand the others, you'll see that they do match the original. So choice 2 is definitely correct. Question 23, the height of a running trail is modeled by the quartic function y equals f of x shown below, where x is the distance in miles from the start of the trail and y is the height in feet relative to sea level. And then we have this graph here, and the question is, if this trail has a minimum height of 16 feet below sea level, which function or functions could represent a running trail whose minimum height is half of the minimum height of the original trail? And then we have these 3 options to choose from. So for this question here, look at this information here. They're telling us the minimum height is 16 feet below sea level. So if we look here, we could definitely see that the lowest point on the graph is occurring at negative 16 on the y-axis. And what they're telling us, though, is to look for functions that would have a minimum height that is half of the minimum height of the original trail. So if the original minimum is negative 16, if we divide that by 2, we're looking for functions that have a minimum of negative 8. Okay, so that's what we're going to be considering when we are looking at Roman numerals 1, 2, and 3. Okay, so that's the number that we're focusing on. Well, I'm looking at Roman numeral 1 and seeing right away that this one is out. Yes, there's a 1/2 involved, but think about what happens when you replace the values here. So we have y equals f of 1/2 x. When we replace these values with half of the original value, well, this is not going to affect the height of the graph. When we replace the x's with 1/2 x, that's going to stretch the graph out horizontally. Okay, so that's going to make it, I always think of, let's say, a sine curve. So if I was thinking of a sine curve, like let's say I just have sine of x. Sine of x looks something like this. When I replace the inside, the argument, with 1/2 x, that just stretches the graph out. So it's just going to take longer to complete a full cycle now. So it's going to stretch it out like this horizontally, but the height of the graph is going to remain the same. So that's why Roman numeral 1 is out. And now we look at Roman numeral 2. This one is good because if we have y equals f of x plus 8, what this is going to do, it's going to shift f of x. So it's going to shift f of x, and f of x is going to go up 8 units. Okay, so if we send it up 8 units, the lowest point is going to go negative 16 plus 8, which is going to make the lowest point at y equals negative 8, which is exactly what we were looking for when we were told this information here. We're looking for a minimum height that is half of the minimum height of the original trail. So 2 is definitely good, which means that these answer choices are out. But now let's see, is Roman numeral 3 good? So for Roman numeral 3, we have y equals, I'll write it over here, y equals 1/2 times f of x. And what this is basically doing is it's taking the function here, f of x, and it's shrinking it down vertically by a factor of 1/2. So that means the highest point is going to get cut in half and the lowest point is going to get cut in half as well, which would bring this point at this location up to -8. So let's say I'll just put the value c here, that I'll say that on the graph of f of x, so I'll just say over here that f of c, let's say that's the location where the function value is equal to -16. Well, if I look at my new function over here, I have y equals half of f of c. F of c is equal to -16, so that would give us half of -16, which would give us -8, which is the exact value that we're targeting here. And that would be the new minimum. So Roman numeral 3 is good, which makes our answer here choice 4. Question 24, the crew aboard a small fishing boat caught 350 pounds of fish on Monday. From that Monday through the end of the week on Friday, the weight of the fish caught increased 15% per day. The total weight in pounds of fish caught is approximately, and we have these 4 options to choose from. Well, for this question, first I want to show you the common sense approach. Okay, so I'm noticing that some of the answer choices over here are very small. So using common sense, let's pretend that the amount of fish caught was not increased at all. Okay, let's just say they caught 350 pounds of fish on each of the 5 days and nothing was increased. Well, Monday through Friday is 5 days. So if I do 350 times 5, let's work this out. 5 times 0 is 0. 5 times 5 is 25, carry the 2. 5 times 3 is 15, plus 2 is 17. So that would mean that the crew caught 1,750 pounds of fish, and this is if there was no increase. Let's say it just stayed the same. But notice every single answer choice except the last one is less than 1,750. So they had to have caught more than this because the amount was increased. So just by common sense, choice 4 is our answer. But now, how can we show this mathematically? So we're going to use geometric series for this. So the first day, Monday, the crew caught 350 pounds of fish. Okay, so they caught 350. But then they increased the amount that they caught by 15% each day. So this is where I'm thinking of this formula, but this formula is also very dangerous. The a equals p times 1 plus r to the t power. This formula is very dangerous because a lot of students are just going to find out how much was caught on the 5th day, and they're going to make that their answer. But they're saying how much fish was caught in total. Okay, we're looking for over here, we're looking for the total weight. Okay, so that means we have to add up the amount caught each day. Well, on the next day here, if we look at the rate here, r, is 15%. And as a decimal, this is equal to, we have 15 over 100, which turns into 0.15. Okay, so that's the decimal here. So the 1 plus r, this part, the 1 plus r, is going to work out to 1.15. So on Tuesday, the crew caught 350 times 1.15. But then on Wednesday, they caught 350 times 1.5 times another 1.15. So let me say that again. 350 times 1.15 times another 1.15, okay, which would bump this up to 1.15 to the second. Okay, and then this will continue on to Thursday, where they caught, and I'll just make a little bit of space here. So Thursday, we're going to say that they caught another power. We're just going to bump that power up. So Thursday, they caught 350 times 1.15 to the 3rd power. And then Friday, the final day, the crew caught 350 times 1.15 to the 4th. So this we could just type right in the calculator. Now, you could just type in all of this here, but that might get a little tiring. So you could also press math and go up to summation here, so option 0. And I could use the letter x if I want. So let's say I go from x equals 0, and then I go up to a power of 4. So I'm going to go from x equals 0 to 4. And if I plugged in x equals 0, then 1, 2, 3, 4, that's 5 terms, which are going to match the 5 days of the week here. And now for the summand, the term inside, I have 350, and I'm multiplying by 1.15 to the power x. And now a quick mental check that what I have here is good. If I plug in, I'm starting at x equals 0. 1.15 to the 0 power is equal to 1 times 350 gives me my first term. And my last term is 350 times 1.15 to the 4th. And now I press enter, and notice that this gives us 2359.833, which is approximately 2360. So choice 4 is definitely correct. So now we're moving on to part 2. There's 8 questions here, and each one is worth 2 credits. Question 25, describe the translations that map f of x equals log x to g of x equals log of x plus 3 minus 5. And when I look at something like this, the first thing that jumps out is that the x is being replaced with x plus 3. And anytime you replace the x's in the function with something like x plus something, that means you're going to the left. It's very tempting to say to the right 3, but just know when you're replacing this stuff inside the function, it's actually going opposite, okay? So this is sending us to the left 3 units, okay? So we're going to the left 3, but then the constants that we attach by addition or subtraction away from the x's are going to shift us in the vertical direction, okay? So we're going to go to the left 3, and in this case here, we're going to go down 5. So the constants on the outside behave normally. So minus 5 means down 5, but when we replace the x's inside the function, then that's going to go opposite. So instead of going to the right 3, we're going to be going left 3. If you forget the rules for a question like this, you could just type the functions into the y equals section. So we have y1 equals log of x, and I'll close the parentheses. And then for y2, we're going to have log of x plus 3, and then we'll write minus 5 at the end. If you need to, you could press zoom 6 to put the graph back to normal. And here are the two functions. So f of x I graphed in blue, and then g of x I graphed in red. And notice to get from the blue one to the red one, we're going to the left 3 units, and then we're going down 5 units. Okay, so the map is looking good. So now we'll just write out the answer. Question 26, solve algebraically for x. And we have 1 over 2x minus 5 over 6 equals 3 over x. And for a question like this, what I'm thinking of is I'm thinking of the least common denominator of the 3 fractions that we have in this equation. So I notice there's a 2 and a 6, and 6 is the least common multiple of 2 and 6. And then we have an x here and an x here. So an x is going to be a part of our least common denominator. If there was an x to the second power here for some reason, then I would include the square here. So it's the highest power of x that shows up in the denominator that would get tagged along in the least common denominator. But since we only have an x to the first, our least common denominator is going to be 6x. So now what I do is I take this equation and I multiply everything by 6x. Okay, so I'm going to rewrite this equation out, and we're going to multiply everything by 6x. So let's do that. So we have the first term here. I'm going to multiply by 6x, and then we're going to do times 6x over here, and then we'll do times, we'll just make this a little neater. So we have times 6x, and then we do times 6x for this piece over here. Now, one thing to point out in the beginning, notice that we have an x in the denominator. So I'm just going to mention that x is not allowed to equal 0. Because if we get a 0 for x, if we were to plug it back into the original equation, we would have division by 0, which is undefined. So I just like to write out which x values are not allowed right in the beginning. So now notice that we have over here, x over x cancels out. 6 divided by 2 is equal to 3. And then we have minus 6 over 6 cancels, and we're left with 5x. And then we have equals x over x cancels, and we have 3 times 6 is equal to 18. So now all we have to do is solve for x. So we're going to go minus 3 on both sides. And this is going to give us on the left side, negative 3 minus 3 canceling. And we have minus 5x is equal to 15. And now we just divide both sides by negative 5. And this tells us, we could say here that x is equal to negative 3, because we're just doing 15 divided by negative 5. Now, one thing, if you're not confident in this algebra, you can just do this question in the calculator, but you're not going to get full credit. You're only going to get 1 point out of 2. So you can just write in 1 over 2x, and after the 1 over 2x, we're going to have minus 5 over 6. So I'm going to press alpha y equals enter to pull up that blank fractions. We have minus 5 over 6, and then the right side is going to be 3 over x. Okay, so I'm just going to write 3 divided by x like this. And now I press graph, and notice that these two graphs intersect over here. So I'm going to press second trace 5. And we could see, I'll just go over to this part of the graph. I'll hit down and go over. Actually, I just got to go all the way to the left like this. Okay, so I just scroll to the neighborhood. So I press second trace 5, and now I just press enter 3 times. And we have x equals negative 3, y equals negative 1. So if you just wrote x equals negative 3, you would get at least 1 point out of 2. So another thing to point out, if this were a 4-point question and they said do this algebraically, and you just draw a sketch of the graph and say, hey, I traced the intersection point, and you write your answer that way, doing it non-algebraically, then you get half credit. So you get 2 out of 4. Okay, so this is just something good to point out, because if you're worried about a question, it's better to get some credit than no credit. But either way here, we're going to be getting x equals negative 3. Question 27, given cosine theta equals negative 2 over 7 with theta in quadrant 2, find the exact value of sine theta. So for something like this, I like to draw out the 4 quadrants, and I label it ASTC like this. And since we are in quadrant 2, that tells us right away that this value here for sine theta, that this is going to be positive. Okay, and it's once again because theta is in quadrant 2. And that's what this S means. It tells us that sine and its reciprocal are positive in quadrant 2. So if I just draw something out here, I'm just going to draw out the angle theta like this, and it's some angle that terminates in quadrant 2. What we do for a question like this is we make a right triangle and we identify, so I'll just make this a little bit neater. We make the right triangle and we identify the reference angle. Okay, the reference angle is the positive acute angle between the x-axis and the terminal side of the angle. And then what I do is I use the given ratio to help me fill out this triangle. So in general, I just think of SOHCAHTOA. So SOHCAHTOA, what that tells me is that cosine is the ratio of the adjacent side over the hypotenuse of that right triangle. Okay, so this is like our reference triangle here. So I'm going to label the side adjacent to the reference angle 2, and I'm going to label the hypotenuse 7 like this. And now what I'm going to do is I'm going to use the Pythagorean theorem to solve for this missing side over here. We could put a letter there temporarily, like let's say we call this b, and I could say that 2 squared plus b squared is equal to 7 squared. And then if I work this out, this is going to give us, we're going to have 4 plus b squared is equal to 49. And now we could solve for b. I'm going to go minus 4 on both sides. And this is going to give us, we're going to have b squared is equal to 45. And now I take the square root of both sides, and this tells us that b is equal to square root 45. So now I'm going to write this over here. I'm just going to say that this is equal to square root of 45. And what we could do now is find sine theta. We could get the exact value, which means it should be in radical form. So now sine of theta is equal to, we could just say it's equal to the ratio of the side opposite of theta, or in this case, our reference angle. So we have square root of 45 over the hypotenuse is 7. Okay, so the whole point of these questions is, once again, to draw in a reference triangle, but you really have to pay attention to what quadrant you are in. If, let's say, instead we were in quadrant 3, then our answer would come out negative because only tangent and its reciprocal are positive when you plug in angles that terminate in quadrant 3. Okay, but here we could say that sine theta is square root 45 over 7. Now, one thing we could do to check our answer, I'm going to hit second mode to go back to the main screen, and I'm going to switch over to degrees. And what I'll do is I'm going to write in cosine inverse. I'm going to press second cosine and type in the ratio -2 over 7. And that tells us that theta, the exact angle in quadrant 2, is 106.6 degrees if we round to the nearest tenth. So now if I do sine of that angle, I'm just going to copy it over here like this, I get this value. But they said to find the exact value. So if we had just plugged in and gotten the decimal value, we would get partial credit, but we wouldn't get full credit. But if we want to check our answer, we could press second square root and write in 45 and then divide this by 7. And notice that we get the exact same decimal. Question 28, given a is greater than 1, use the properties of rational exponents to determine the value of x for the equation below. And for this question, we should know the following 3 properties. We should know that the c root of a to the b power is equal to a to the b over c. Just tell yourself power over root. Okay, so that's how we go from that radical form over to rational exponent form. And then the next property we should know is that a to the b to the c power is equal to a to the b times c. And then finally, we should know that a to the b divided by a to the c is equal to a to the b minus c. So I'm going to use these 3 properties here for this question. So first I'll use that power over root concept. So I'm going to rewrite this up here, the 5th root of a to the 10th, as a to the power 10 over the root 5. And then for the next part here, so in the denominator, I'm going to write this part here as a to the, I'm using the second property, I'm going to do 3 times a half. I'm going to write this as a to the 3 over 2. Okay, and we'll just make this a little bit neater. So we have a to the 3 over 2 like this. And now this is all equal to a to the x. Okay, so this is equal to a to the x power. So now we'll use the third property. So we're going to have a to the 10 over 5, which is 2. So I could just simplify this here as 2. So I have a to the 2 minus 3 over 2. And this is equal to a to the x. And now I just have to subtract these 2 numbers. So 2 minus 3 over 2, I'm just going to write that as 4 over 2 minus 3 over 2. and that's equal to 1/2. So I could say here that a to the 1 over 2 is equal to a to the x. But now let's make sure we're answering this question. They said to use the properties to determine the value of x. So I'm just going to say here now that x is equal to 1/2, and then this is our answer to question 28. Question 29, graph at least one cycle of y equals 5 times sine of 4x minus 3 on the set of axes below. So for questions like this, we just have to know what each term means. So the 5 in front of the sine, this is the amplitude of the graph, which tells us how high up the waves go. Okay, so that's the amplitude. And then next, the 4 over here, this tells us the frequency. So that would be the frequency of the graph, which is how many cycles complete over an interval of 2 pi. And then finally, the last part here, the minus 3, that's the midline. So I use all of this information to get a nice graph below. So first I like to do the midline. We have a midline at -3. So that's down here at -1, 2, 3. So I'm just going to draw in, we have a midline over here like this. Okay, so this is the sort of like the halfway point of the sine curve. And then the next thing to know here is the amplitude. This tells us how high up and down to go. So the amplitude, we count 5 up from the midline and we go 5 down from the midline. So we're going to go up 1, 2, 3. So I'll just make this neater. So we go 1, 2, 3, 4, 5. So this tells us the max height is going to be at 2. And then the minimum height we could find by going 5 down. So we're going down 1. So 1, 2, 3, 4, 5. And now we just count. This is going to bring us down to -8. Okay, and I'm going to write in the midline here is at -3. I could just see if I do -3 minus 5, I'm going to get -8 like this. And now the next detail to look out for is the frequency. So one thing to know is that the frequency is equal to 2 pi divided by the period. And I could also swap these and say that the period is equal to 2 pi over the frequency. So in terms of graphing, the period is very useful because it tells us how far out to go in the x direction. Okay, so the period here for our graph is going to be 2 pi divided by the frequency, and the frequency is the coefficient of x, which is 4. So now I could say that the period is equal to pi over 2 if I reduce this. So I don't necessarily have to count to a specific amount, but let's say I put pi over 2. I'm going to put it out 1, 2, 3, 4 like this. I'm going to put pi over 2 all the way out here. Just know that in general, if I think of a sine curve, that the sine curve has 4 sections. Okay, so if I just think of a random sine curve like this, so I'm just going to draw it out like this. It has 4 sections. So the sections are going to go from here to here. So this is one section. This is the second section over here like this. The third section would be the bottom swing like this, like going down to the low point. And then the fourth section would be this part here. So when you find the period, it's also good to think about what is the period divided by 4. Okay, so when you want to divide something by 4, what you could do is you could divide it by 2 twice. So I could do times 1/2, and that tells me pi over 4, which is going to tell me the halfway point. That's over here. So this is pi over 4. And then I could also just cut that in half again. So if I cut it in half again, so that's just one more thing to think about. If I cut it in half again, I do pi over 4 times 1/2. This tells me pi over 8, which would represent this value over here. Okay, so pi over 8 would be over here. And this is what we're counting by. So I like to think of this as if I had pi over 8, then next I would have 2 pi over 8. Then I would have 3 pi over 8, and then 4 pi over 8 if I'm just counting by pi over 8s. And notice that 4 pi over 8 is equal to pi over 2. 2 pi over 8 is equal to pi over 4. So this mystery value over here is 3 pi over 8. And then if you're graphing a sine curve and there's a positive coefficient in front, the sine curve starts off on the midline. So it goes midline, and then it goes up to the max here. And then it goes back to the midline, it goes back, and then it goes down to the min, and then it goes back to the midline. So when I sketch this out, I'm going to start off here on the midline like this. And then at pi over 8, I'm going to go up to the max. So I go midline, max, back to the midline, and then I go down to the minimum here, down at -8, and then I go back to the midline at pi over 2. But remember, these are the significant points here to plot. And then when I sketch my full cycle, I just connect it with the sine wave like this. I'm going up, down, and then I go down like this, and then I go back up. And this would get us full credit. But before I move on, I always like to check my graph. So I'm just going to go over here and type the y equals into this part over here. Okay, so I'm going to type in, we have 5 sine of 4x, close the parentheses, and let me just fix that. So we have 4x, and then we have minus 3 on the outside. And we have to press mode and go back to radians like this. And if I press graph, this really doesn't help us at all. So what I'll do is I'll shrink it to the window of just the single cycle that I graphed. Okay, so they said to graph at least one cycle, but of course I'm just going to graph one here because it's a lot of extra work to keep graphing this. So I'm going to go to window and I'm going to make my x minimum 0 and my x maximum I'm going to stop at pi over 2. So I'm going to go to pi over 2. And then for the minimum value, I'm going to make it -8 because that's the low point of my graph. And then the high point of my graph is at 2. And now we press graph, and there's the there's the complete cycle of the graph. If I type in the equation of my midline, if I type in y equals -3, notice that this cuts the graph nicely, just like it shows up on the graph. So this graph here is definitely good. Question 30, the cost of a brand new electric hybrid vehicle is listed at $33,400, and the average annual depreciation for the vehicle is 15%. The car's value can be modeled by the function v of x, where x represents the years since purchase. Julia and Jacob have each written a function that is equivalent to the original. So here's Jacob's function v of x, and here's Julia's function v of x. And we want to know whose function is correctly rewritten to reveal the approximate monthly depreciation rate, and we have to justify our answer. So for this question, a very important detail is that x represents the years since purchase. And we're trying to see who correctly rewrote the function to reveal the approximate monthly depreciation rate. Okay, so we're going from years to months. So the idea is if x represents years, so let's think about this. If it's x years, how many months is that? Well, if you think about this conversion over here, 1 year is equal to 12 months. Okay, so 1 year is equal to 12 months. So that tells us that the number of months here, we would just say is 12x. Okay, so 12x months like this. So if you think about it, and you could just think about this with a random number of years, like let's say x is equal to 2. 2 years would be 24 months. We would do 12 times 2. Okay, so this is how we go from x years to months. We would just multiply by 12. So if they're telling us that we have to see who correctly rewrote the function to reveal the approximate monthly depreciation rate, then we should be thinking of 12x months. And right away, Julia's function is jumping out like this. Okay, so for this one, how we could justify this though is we could take the starting function v of x, and we have 33,400. And then we have this function here, like the rest of the function over here is 0.85 to the x power. But what we're going to do instead is we're going to use this property of exponents. When we have a to the b to the c power, this is a to the b times c. So I want to rewrite x. X I'm going to write as we're going to have 1 over 12 times 12x like this. Okay, so I'm going to write this now as 0.85 to the 1 over 12. And then this I'm going to raise to the 12x power. And the reason why I'm putting the 12x on the outside is we're writing this in terms of months because we want to know who correctly rewrote this to reveal the approximate monthly depreciation rate. So that's why the 12x is going on the outside. And now we would just have to see in the calculator if this works out to match Julia's decimal. So we could go back on the main screen and we're going to type in, we're going to have 0.85, and we're raising this up to the 1 over 12 power. And this is going to give us here, if we look, we have 0.9865, and to the right of the 5 is a 4, so we would round down to 0.9865. So Julia's function is looking good. So now we could just record this result. We have v of x is equal to, we have 33,400, and then this part we did in the calculator, 0.85 to the 1 over 12 is 0. And then we have 9865. And this is all being raised to the 12x. And this one matches Julia's function. So the question is asking whose function is correctly rewritten. So we're asking here who did this correctly. Julia did this correct. So we could say Julia is correct. And we don't have to say any more because the question is just telling us to justify. Okay, so the question says justify your answer, which just means we have to show supporting math to get to the conclusion here. So this would get us full credit. Question 31, write a recursive formula for the sequence, and we have 8, 20, 50, 125, and then 312.5. So for this one, this is not looking like an arithmetic sequence because we're going up 12 and then 30, and then after this it's going up, let's see, 75. So it's not going up by a fixed amount. So this one, I'm going to take an educated guess here that this is geometric. But the way to find out if this is geometric is to take any two consecutive terms and divide one term by the one before it. So if I do 20 divided by 8, this one I could reduce down. If I divide the top and bottom by 4, I'm going to get 5 over 2, and this simplifies to 2.5. And if I want to double check, I could do 20 times 2.5, and you see how this works out to 50. So this one is a geometric sequence, but we have to write a recursive formula for this. Okay, so for this one, we have to define the first term is equal to 8, but then think about how do we get from one term to the next? We're just going to continuously multiply by 2.5. Okay, so the common ratio here is 2.5. So to indicate that with the formula that's recursive, we're going to say 2.5 times the term before it. And the term before a sub n is a sub n minus 1 like this. Okay, so this would be a recursive formula to model this sequence over here. Question 32, a grocery store orders 50 bags of oranges from a company's distribution center. The bags have a mean weight of 3.85 pounds per bag, and the company claims that their bags of oranges have a mean weight of 4 pounds. The grocery store runs a simulation of 50 bags 2,500 times, assuming a mean of 4 pounds, and the results are shown below. And then the question is the mean weight of the grocery store sample unusual, and we have to explain using the results of the simulation. Now, for questions like this, I usually have to reread them more than once because there's a lot of information here, and we want to think about which value are we trying to see if it's unusual. Okay, so that's the theme here, is we want to see if some value is unusual using the results of the simulation to explain our answer. So anytime I hear this phrase, is the value unusual, I want to see if this value is within 2 standard deviations of the mean. Okay, so we're going to take the mean and we're going to go plus or minus 2 standard deviations. But now I reread the question in the beginning and see which value are we analyzing. So the grocery store orders 50 bags of oranges from a company's distribution center, and the bags have a mean weight of 3.85 pounds per bag. And then the company is claiming that their bags of oranges have a mean weight of 4 pounds. So the simulation is based off of the company's claim. And the actual bags that showed up to the store, these are the ones we're analyzing in reference to this simulation here. Okay, so now we could just type these values in the calculator. So we're going to take the mean and we're going to find plus or minus 2 standard deviations of the mean. So I'm going to take the average and I'm going to go minus 2, and 1 standard deviation is 0.026. So I'm basically just building up our middle 95% interval, okay, our 95% confidence interval. And this is our lower limit here. And then for the upper limit, I'm just going to go up to the entry here in the calculator, press enter, and I'm going to change that minus to a plus. And this is going to give us the upper bound here. So these are the values we're going to use. So now I'll just record the results here. We're doing 4.001. And we're doing plus or minus 2 standard deviations, and the standard deviation was 0.026. And what this tells us, it tells us that our 95% confidence interval, so our 95% confidence interval is, and we're just going to use the values that we had in the calculator. Okay, so the small value here, the beginning of our interval, is going to be at 3.949, and the end of the interval is going to be 4.053. So now we look at that value of 3.85 and notice that it's not in this interval. Okay, it falls outside of the interval, which tells us that the value 3.85 is unusual. Now, one more thing I want to point out, I did see a sample response where a student wrote something that was really, really cool. What they mentioned was they said that 3.85 doesn't even show up in the simulation. Notice that 3.85 is not even one of the entries here. So the fact that that value doesn't even show up says that it's not going to fall within the 95% confidence interval. And that's a very short response, but this is a 2-point question, and that response would also get full credit. So now we're moving on to part 3. There's 4 questions here, and each one is worth 4 credits. Question 33, at the lakeside resort, the probability that a guest room has a view of the lake is 0.24. The probability that a guest room has a queen-sized bed is 0.74. Let A be the event that the guest room has a view of the lake, and let B be the event that the guest room has a queen-size bed. Events A and B are found to be independent of each other. Determine the exact probability that a randomly selected guest room has a view of the lake and a queen-size bed. So this is the million-dollar phrase right here, that the events are independent of each other. So if A and B are independent, that means the probability of A and B occurring, and this is the notation for the probability of A and B occurring. We put this little upside down U here. We could say that this is equal to the probability of A times the probability of B. And once again, this follows because they're telling us here that events A and B are found to be independent of each other. So now we could just find this probability by plugging in. The probability of A and B occurring is equal to the probability of A, they told us, is 0.24. Okay, they said let A represent the event that the guest room has a view of the lake, and the probability that a guest room has a view of the lake is 0.24. So we're multiplying this by the probability of B is 0.74 because B represents the event that the guest room has a queen-size bed. So we just multiply these two values together. So now let's type this in. We have 0.24 and we're multiplying by 0.74. And we get this decimal here. And just be careful, the question is asking for the exact probability. So we're going to write out this entire decimal. So our solution to the first part is 0.1776. For the next part, we're going to determine the exact probability that a randomly selected guest room has a view of the lake or a queen-size bed. So for this one, we're finding the probability of A or B occurring. And for this, we're going to do the probability of A plus the probability of B. But we have to be careful, make sure that we subtract the probability of A and B occurring. And the concept behind this is if you think about a Venn diagram, and for the Venn diagram, I'm going to label it A and B. If I do the probability of A plus the probability of B, and notice that this overlapping region here gets added twice. So when I do the probability of A plus the probability of B, the overlapping region gets added twice. That's why we have to subtract it out once so that it only gets counted once. Okay, so that's why this formula takes the shape that it does. So now we just have to plug in. We're going to have the probability of A or B occurring is equal to the probability of A is 0.24. And then we have plus the probability of B is 0.74, but we're going to subtract out the value we found in the first part, the 0.1776. So let's type this in. We have 0.24 plus 0.74, and we're going to subtract 0.1776. And we get this decimal here. So now let's write out our final answer and make sure that we're writing the exact probability. So we have the probability of A or B occurring is equal to, and then we have 0.8024. Question 34, which function has a greater average rate of change on the interval -1, 4? And we have to justify our answer. And we have the functions m of x, which we have this table of values for, and then p of x, we have an explicit function for. So I'll find the average rate of change of m of x first. And we're going on the interval here from -1 to 4. So we're going to find m of 4 minus m of -1, and we're going to divide by 4 minus -1. Okay, so this is our average rate of change for the function m of x. And we just look at the table here. M of 4 is equal to 81. And then we have minus m of -1 is the y value over here is equal to 1. And we're dividing by 4 minus -1 is 5. And this gives us 80 divided by 5, which is equal to 16. Okay, so that's our average rate of change for m of x on that interval. And now we'll find the average rate of change for p of x. So now we're going to find p of 4 minus p of -1, and we're dividing by 4 minus -1. So we'll just type this in. We have 3 to the 4th, and then plus 1, because this is finding p of 4. I'm just going to plug in x equals 4 into the function p of x. So this is the value here that we're going to be plugging in. And then we also have the function value at -1. So now I'm going to replace the x with -1. So I could just go up to this and go to the exponent and switch out the 4 with a -1 like this and press enter. So now that I have these two values here, I'm going to press alpha y equals enter. And I'm going to do the first value here, so 82. And then minus, I'm going to type this one in by just going up to it and pressing enter. And then I'm going to divide by, in the denominator, we have 4 minus negative 1. Okay, so we have 4 minus negative 1, and I'll pretend that I don't know that that's equal to 5. So now I'll just plug in. We have p of 4 was equal to 82, and then we have minus p of negative 1 was 1.3 repeating. Okay, so I have 1.3 repeating like this, and we're dividing by 5, and this simplified to 16. So we have 16.13 repeating. And the question is asking us which function has a greater average rate of change on the interval. And the function that wins here is p of x. So I'll just state out the answer formally here. I'll say p of x has a greater average rate of change on the interval negative 1, 4. And remember, for this question, we only have to justify our answers. So the work that we show here is sufficient to get us full credit. Question 35, determine an equation for the parabola with focus negative 2, 4 and directrix y equals 10. The use of the grid below is optional. These questions could be very tricky, so I 100% recommend that you use the grid to do them. And the key to these questions, I would say, is being able to visualize what's going on so that you could get to the answer. Okay, if you memorize formulas, you'll probably be successful with some of them, but I would say for this topic, you have to be able to visualize what's happening. So we have a focus at negative 2, 4. So that's over 2 and up 1, 2, 3, 4. And then the directrix is at y equals 10. So I'm at 4. I'm going to go up 5, 6, 7, 8, 9, 10. So this is where the directrix is. So this is just to help us visualize what's happening. We're not going to actually be graded on what we put here, but this is just here to help us. For some questions, the grid is optional and the work can count whatever you put on the grid, but I'm just going to use this space to help us build our equation, because what I'm thinking of is I'm thinking of y equals 1 over 4 times p, and then we have x minus h, I'll make this neater, x minus h squared, and then plus k, where the vertex is at hk. Okay, so I'll explain what the p-value represents in a moment, but this is the formula that we want to be using. So next we have to know the concept of a parabola. So a parabola, if it smiles at you like this, then the focus would be somewhere over here and the directrix would be underneath like this. And the idea of a focus and directrix is that a parabola is the set of all points that are the same distance away from the focus as they are from the directrix. Okay, so we would say that all of the points are equidistant from the focus and directrix, no matter where we are. And the same thing is true if we have a parabola that's upside down like this. Okay, in this case, the focus is on the inside and the directrix is above like this. So we could see if I were to put, let's say, this point over here, the distance from here to here is the same as the distance from here to the focus. So that concept allows us to see that our parabola is going to be opening this way because the directrix is above the focus. Okay, I'll put a capital F here for focus, and then this one here, I'll put a capital D for directrix. Now, the point that's most useful to find for these questions is the vertex. Okay, the vertex is directly in line with the focus and the directrix. So that's the point I want to find. And notice I have to go up 1, 2, 3, 4, 5, 6. So if I go halfway, I go up 1, 2, 3. This would bring me to the vertex. So now I'll identify the coordinates of the vertex. So that's to the left 2, and then up 1, 2, 3, 4, 5, 6, 7. So the vertex is located, I'll say over here, the vertex that we're looking for is located at negative 2, 7. And now the next thing to look for is the p-value. The p-value is the distance from the vertex to the directrix or the vertex to the focus. So over here, we could just count the space is 1, 2, 3. So this tells us that the p-value here is equal to 3. So now we have everything we need to find our equation. We're going to say y equals, and we're going to have 1 over 4 times 3. But then the catch here is to understand the concept that this parabola is going to be opening downwards like this. Okay, it's going to be opening this way, going in this direction. So that detail allows us to say that our coefficient has to be negative. Just know if your parabola is opening upwards like this, then you're going to have a plus in front. And if it's opening downwards, you're going to have a minus. So in this case here, we're going to be going with the minus because it's the situation where we have the directrix above and the focus underneath, and the vertex is always in the middle. Okay, so here we're going to say y equals negative 1 over 4 times 3, And then we have x, I'll just make this neater. X minus h is -2, so x minus -2 becomes x plus 2. And then we square it, and the k value here is 7, so we just write plus 7 on the outside. And now simplified, this is y equals -1/12 times x plus 2 squared, and then plus 7. And this is the equation that we need. Question 36, algebraically find the zeros of c of x. And then after that, on the set of axes below, we're going to sketch y equals c of x. So for this one, what I'm noticing is that we have 4 terms. So I want to try factoring by grouping first. So I'm going to go 2 terms at a time here, and I'm going to take out the greatest common factor in pairs. So we're going to have x squared, and if we divide each of these things by x squared, we're going to have x plus 2 left. And then over here, I'm going to take out a minus 16 because the goal is to get a matching binomial with x plus 2. So if we factor out a minus 16, negative 16x divided by negative 16 is x, and then negative 32 divided by negative 16 is plus 2. And we're going to set all of this equal to 0 because we're looking for the zeros of c of x. So now from here, we could factor out x plus 2, and we're left with x squared minus 16 is equal to 0. And for this over here, we have a difference of 2 squares. So this one we could break down to x plus 4 times x minus 4. And the x plus 2 over here is just going to tag along. And this is all equal to 0. And then from here, we should just know that factors and roots have an opposite relationship. So this is going to give us x equals -2 as one of the zeros. This one will give us x equals -4. And the last one is going to give us x equals +4. So these are the 3 zeros of c of x. So now let's sketch a graph of y equals c of x. We have a root at x equals -2. So I'm going to go over to the graph here and plot the point -2, 0. We have another root at x equals -4. So I'm just going to plot this point over here. And then we have our third root at x equals +4. So that's 1, 2, 3, 4. And we just color it in like this. I would even label this over here, say x equals -4, -2, and then +4 like this. But we are just making a sketch, so we don't have to worry so much about labeling the x and y axis. And now from here, we could use the calculator, but a nice little trick that you could use is when you're thinking about the end behavior of a polynomial. The end behavior of a polynomial is entirely determined by the leading term. So here, notice that the leading term is x to the 3rd power. So I have y equals x to the 3rd. That's what I'm thinking about. And for this graph, it goes like this. And what this tells us about c of x is that the end behavior is going to be identical to the end behavior of x to the 3rd. So when I'm doing this without a calculator, what I'm thinking about is as x goes to infinity, notice as we go all the way to the right, the graph is going up. So that tells us that c of x should be going up as well to infinity. And then we could also say as x goes to minus infinity, the graph of c of x is going to go to minus infinity as well, because the graph of x to the 3rd, the leading term of c of x, is going to minus infinity as we go all the way to the left. So that's how I do this without a calculator. So now I'll just draw this in. That tells us that as we go to negative infinity, the graph is going to be dropping down like this, which means that the graph is going to go up like this, back down, and then it's going to go up like this. All right, let me just draw that a little bit neater. I'll try that again. So it's going up, down, and then back up again like this. And as we go all the way to the right, the graph is going to go up to infinity. And remember, they are saying just sketch. What they are looking for in your sketch is that your roots are accurate and that your end behavior is accurate and that you draw something smooth. Don't draw something that's zigzagging like this sharply. Make sure that you're drawing it in one motion and smooth. But of course, before you go on, you should absolutely check and see that what you graphed matches what the calculator is showing. So we have y equals, and I'm going to go over here to x to the 3rd. So we have x, and then we press the power button, and then to the power 3, and then we have plus 2x squared, and then we have minus 16x, and then at the end we have minus 32. Okay, and I'm going to press zoom 6 to put the graph back to normal. And here, if I press second graph, notice that when x goes out to 10, we're up to 1008. And when x goes out to negative 10, we're down to negative 672. So I'm going to go to the window here, and I'm actually going to bring this out to, let's say I go negative 1500 to positive 1500. That way I get a really nice picture of what's happening. And now I press graph, and notice that our graph here, it's going up, down, and up. And I know at the roots here, it might be a little bit tricky to see what's happening. So maybe just for a moment, I'll switch this to like, let's see negative 100 and positive 100, just so that we get a better picture of what's happening. And notice that it kind of matches what we have here. It's going up and then down and then back up again like this. So this is not the best sketch in the world in terms of like, being like, super like neat. But remember, it's a sketch. They are looking for the roots and they are looking for the end behavior. This would get full credit. So now we're moving on to part 4, the final boss, and this question is worth 6 credits. Question 37, the populations of honeybees in 2 different colonies are studied for 4 months. During this time, the colony population can be approximated by P of t, where P of t is the colony population of bees at t months, P naught is the initial population, and R is the growth rate. Colony A has an initial population of 10,000 bees and a continuous growth rate of 0.25. Colony B has an initial population of 6,000 bees and a continuous growth rate of 0.45. Write functions for both A of t and B of t that models the honeybee populations of the colonies after t months. So first, let's come up with the function for A of t. So that's referring to colony A, and colony A has an initial population of 10,000. And the initial population is modeled by P naught, so that's this part over here. And then we have a continuous growth rate of 0.25. So I'll just write that over here. And this is for colony A, which will help us write a function for A of t. So we're going to combine this information over here and say that A of t is equal to, and then we have P naught is 10,000 times e to the RT, and R is 0.25. Okay, and then just times t like this. So that's our function for A of t. For B of t, that's for colony B, we have an initial population of 6,000, and we have an R value of 0.45. So I could say here that B of t is equal to, and I just use that formula again, I could say that it's 6,000 times e to the 0.45 times t. And now from here, we could just type these 2 functions in the calculator. So we have 10,000, and then we have e is second, and then we have natural log, and we're going up to the 0.25 times t power, but we'll use x. And then for b of t, we have 6,000, and then e is second natural log, and we go to the 0.45 times t. And then notice we press graph, we can't see anything. And let's think about why. If we press second graph and look at the table here, and I'll scroll down to the positive t values here, notice that when we go up to about 10, that we're all the way up here to these giant numbers. We have 540,103. So we see this. Maybe I will cap the graph at about, let's say 100,000 and see what happens. Okay, so I'm going to go up to a y maximum of 100,000. And now I press graph, and here we could clearly see the 2 functions. Okay, but they're actually telling us here to graph this on the space from 0 to 4. So I don't need to look at all of this stuff over here. I just need what's going on over here. So when I hit second graph and go to the table, the only values I want from the table are the ones that are over here from 0 to 4. So now we could plot these points, but one thing to be careful of, if we look at the graph over here, notice the y-axis is the bee population in thousands. So what I'm thinking of before I graph anything is I take a y value, let's say this y value of 10,000. And if the y values are in thousands, we have to divide each of these by 1,000. And this would tell us to plot, if I cross off the common zeros here, the starting value here for the blue, I would start off at 0, 10 like this. Okay, so I'm just going to be ignoring the last 3 digits, and I'm only going to be graphing up to the first 2 digits because the y-axis is in thousands. So whatever y value I get, I multiply by 1,000 to get the true number of bees. Now for these questions here, you don't have to break out a magnifying glass to get full credit when you're graphing these, but I do try to make them as precise as possible. So notice for, let's say, this value here at 16,487, that would be a little bit above the mark here for 16. So I just try my best to pay attention to the y-axis scale, because when they are grading your papers, they're going to be looking to see, how precise you are. They're not going to go down to like, let's say the millimeter, but let's say I were to graph 16 like way up here or something, they would definitely mark me wrong for not being accurate. So next, we're going to state to the nearest tenth of a month when the colonies will have the same population. So for this one, if we look at the graph, we're looking for the point of intersection. So we could press second trace number 5, and we could scroll over to the point of intersection like this and press enter 3 times. And they asked us to round to the nearest tenth of a month. So that would be 2.6 we would round to. And one thing to be mindful of here, notice that the t-axis is in terms of months. So that's how I know that there's nothing extra that I have to do here. I'm just paying attention to the units. And in the question itself here, they mention here that t is represented by months. So we'll just write out our solution. We have t equals 2.6. We're rounding to the nearest tenth. And now for the last part, we're going to determine algebraically how long it will take to the nearest tenth of a month for the population in colony A to triple. So one thing to be mindful of is that a of t, the function we wrote before, was 10,000 times e to the 0.25t. So if we want to see how long it's going to take for the population to triple, we have to consider here that the initial population is 10,000. So the math that I'm doing in my head is I'm just taking 10,000 and I'm multiplying it by 3. So that would give us 30,000, and that's what I'm setting a of t equal to. So I have 30,000 equals 10,000, and then times e to the 0.25t. Okay, so this is the setup for the question here. And now I just have to do some algebra. So I divide both sides by 10,000. And on the right side, these terms cancel. And on the left side, when we divide by 10,000, I'll just cross off the trailing zeros here. So we get rid of these 4 zeros and these 4 zeros. And this tells us that 3 equals e to the 0.25 times t. And from this step, what I would do is take the natural log of both sides. And the reason being, natural log and e are opposites. So they cancel each other out. And that'll leave us with, in the next line, we'll have natural log 3 equals 0.25 times t. And then to solve for t, we just divide both sides by 0.25. And for this one, though, we just have to remember that at the end, we're going to be rounding to the nearest tenth of a month. So we could go back to the main screen here, second mode, and we're going to press natural log 3, close the parentheses, and then divide by 0.25. We press enter, and this is the decimal that we need. So our final answer to the nearest tenth, we look at the tenths place is a 3, to the right is a 9. So we're going to round and say t equals 4.4. And this is our solution to the last part.